Okay, welcome to section 1.5, part 2. I actually started recording this earlier and then it stopped and I didn't realize, so now here I am doing it again. Okay, so multiplication, we can think of multiplication as repeated addition. So for example, 3 times 4,000, we can think of this as either 3 4,000 times, or you can think of it as 4,000 3 times. So 4,000 plus 4,000 plus 4,000 would give us 12,000. And some notation for multiplication would be, sometimes I use a star, this asterisk, but more commonly it's a dot. You also have parentheses, and then if you have variables, put them side by side, and that indicates multiplication as well. Okay, so here are some symbols, some common symbols that we use. So, you know, addition and subtraction in words, we use the sum of or plus, okay, just sum. For subtraction, we use the difference of, minus, subtracted from. You know, another thing you can do is like more than, right? Less than for subtraction. Multiplication, the product of, we also have used times or to multiply, right? The quotient of, you know, we just divide, right? And the symbols would be the regular symbol, the division symbol. In a fraction, you're technically dividing the numerator by the denominator, and then this slant one where A is being divided by B. Okay, so another operation that's common is grouping, and you can see we use parentheses, square brackets, and curly braces. And a word that we use to indicate grouping is the quantity. And there are others, but for now, let's just think of the quantity, because sometimes grouping can be implied. When you say, like, let's say the difference or the sum, you imply a grouping, and we'll go over this more when we get into word problems. Okay, so sorry, the notes are already on there because this is my second time. So distributive property. What's the distributive property? If you have a number multiplied by a sum or a difference of 2 or more numbers, you can distribute this number that you're originally multiplying by, you know, by multiplying every term in the inside of the parentheses by the outside number. So A times the quantity, see the parentheses, B plus C is equal to A times B plus A times C. So let's look at that in action. So for example, you have 3 times the quantity 2 plus 4. You can rewrite this as 3 times 2 plus 3 times 4, you would get 18. And if you just had done 2 plus 4 for 6, then you could multiply that and get 18 anyway. Okay, so you can use distributive property to solve larger numbers. Let's say, for example, you have 7 times 65. If I wrote 65 as 60 plus 5, then distributed the 7, it would be 7 times 60 plus 7 times 5, which is 420 plus 35, and gives you 455. So that's one way to do it. Okay, and then just to go over multiplying multiple digits, when you have a 0 at the end, you can kind of, I was just showing this earlier, you can consider the 0 as a like placeholder 0, and then you would multiply the first number by, you know, the non-zero. So let's say here 24 times 4 would be 96, and then you would bring the 0 down. So it would be 960. Okay, and then if you do further, you know, we're multiplying top and bottom, you would take the right hand lower digit and multiply that by every single one, okay, and then bring it down ones place, and then carry over anything greater than that. So let's say, for example, you have here 8 times 5, which is 40. We bring down the 0, carry the 4. 6 times 5 is 30, plus 4 is 34, so bring down the 4, carry the 3. 5 times 1 is 5, plus 3 is 8. And then now we would multiply everything by the 2, so we bring down a 0 because we're technically multiplying by 20, because it's the 2 in the tens place of 25. So 2 times 8 would be 16. 6, carry the 1. 2 times 6, 12. Plus 1 is 3, carry the 1. And then 2 times 1 is 3, plus 1 is 3. And then you would add these two results together, and you would get 4,200, okay? And of course, another way you could do is, you can check your work by using your calculator as well, okay? So for 728 times 91, you can go ahead and pause the video and let's see what you get. So I will wait 10 seconds and you will pause it and then you go through the next two if you can. So let's go ahead. All right, so we have here 728 times 91. So the first one's easy, that's just 1, right? So you would get an 8, 2 times 1 is 2, 1 times 7 is 7, okay? Then 0, 9 times 8 is 72, carry the 7. 2 times 9 is 18, plus 7 is 25, carry the 2. 7 times 9 is 63, plus 2 is 65. And then you would add, okay, what's left over. So you would get 8, 4, 2, 6, right? Carry the 1 because 7 plus 5 is 12. And then 1 plus 5 is 6, and then bring down the 6, 66,248. Okay, and then if you had, you can do this a couple of ways, right? You could use distribution property for all of these actually, but if you had done 555, you could see that you can either do distribution property or just up and down. So let's say here you have 432 times 555. So let's start. You would get 2 times 5 is 10, carry the 1. 5 times 3 is 15, carry the 1, 16. 5 times 4 is 20, carry the 1, that's 21. Okay, so then we're multiplying by this one now, so we bring down to 0. 5 times 2 is 10, right? 3 times 5 is 15, plus 1 is 16, right? 5 times 4 is 20, plus 1, 21. So notice that it's the same exact thing, right? Because we're multiplying. The only difference is now you'll have, for the next one, since you're multiplying by 5 in the hundreds place, you have to add 2 zeros. And then you're going to get the same thing, right? So 5 times 2 is 10, carry the 1, like, right? 15 plus 1 is 16. Carry the 1, 20, this is 21, okay? And then you add the 3 together, and you would get 0, 6, 7. This would be 9, and then this would be 3, and this would be 2. So you would get 239,764 your answer. Okay, great. Okay, what are some applications of multiplication? We use them for area. We use it a lot for area. Remember, area of a rectangle, if you don't remember, it's length times width, right? So we can either think of it as length times width, or base times height sometimes. Base times height, that's another thing that you see out in the world. Okay, so area of a square, so imagine, so if I was to draw here a rectangle, let's say we said this was the length and this was the width. Now a square is, the property of a square is that all the sides are the same, okay? So this little tick mark means that they're the same length, okay? So if a square is a special case of a rectangle with all the sides the same, okay? So basically, so in terms of a square, you can think to yourself, wow, so the length is equal to the width of a square, so we could just say it's a side, right? You know, length width equals the side. Okay, so since that's true, the area of a square, it's we don't just have to say length times width, we could just say side times side. So side times side, and we usually use s squared, okay? So that's for a square. Now let's do rectangle. Find an area of a rectangle with sides 8 and 15 meters. So you have 8, 15. So the area is just going to be 8 times 15. Okay, not too bad. And that's going to be 120 meters squared. That's the unit, okay, when you're squaring. Okay, cool. What are some properties of multiplication? So we have some properties, some super fun multiplication properties. So we have the zero property. So if you have a number times 0, it's the same as saying that's equal to 0. And we can also say that 0 times any number will equal 0. So that's the zero product property. And then we have identity property. So if you have any number But if you multiply that by 1, you get the same number back. So you can also say it in the other direction. So if 1 times any number is going to still be that number. Okay. And then commutative property, we saw this a little bit earlier, but if you have for two numbers A and B, A times B is equal to B times A. And so example of that would be like 2 times 3 is equal to 3 times 2, where they're both equal to 6. Okay. And then associative property, I think we've talked about this, where if you have the sum of 3 numbers, you can regroup them in a different way and solve it. So this is regrouping. Okay, 3 or more numbers. This could apply to more, not just 3. It's not limited to 3. Okay, so let's do an example. Let's rewrite 4 times 9 using commutative property. So 4 times 9 is going to equal 9 times 4, which is 36. And then 4 times 6, so 4 times 6 is the same as saying 6 times 4, which is 24 today. Okay? All right. So what if we want to solve equations involving multiplication? We can do this either mentally, or we can do what's called the inverse operation. So what's inverse to multiplication is division. So if we have 4n is equal to 12, in order to basically like undo the 4 and solve for n, we would divide both sides by 4. And usually we do like this. Okay, we write a little line and say we're dividing, because 4 over 4 is 1. So on the left side you just get n, and on the right side 12 divided by 4 is 3. Now this makes sense because if n is 3, 4 times 3 is 12, and that's true. Okay, so now you try. I'm going to go ahead and wait, and then I will let you guys quickly do these, and we will check our answers. So go ahead and push that pause button. All right, so I'm assuming that we did that. So let's go ahead and solve it. So for the first one, we get n is equal to 4. For the second one, dividing both sides by 4, we get n is equal to 9. The third one, dividing both sides by 3, we get x is equal to 5, or 5 is equal to x. And then the last one, dividing both sides by 3, we get 7 is equal to b, or you can write b is equal to 7, because it's, they're the same. They mean the same. Okay, so that's it for 1.5. This is your homework. Good luck, and I will see you on the next video.